shall start this webinar presentation. I'm Ravi Anand from DIgSILENT Technologies, New Delhi. We are the academic partners of DIgSILENT PowerFactory software, which is an integrated power system engineering simulation tool for generation, transmission, distribution, and its industrial network. So DIgSILENT has set a standard for more than 25 years in the field of transmission, distribution, and network designing. DIgSILENT generally stands for Digital Simulator for Electrical Network. The development work began in 1976. This software is generally belong from the Germany, and we are the channel partners in India. So DIgSILENT they have just updated with 2016. The 16th version is now being in processed, and we are using 16th version. So that time, the first simulation tool in the market in 1976, when the development work was started, the software was the only simulation tool available in the market at that time. Later, different tools have come to the market, but it was the initial one and mother of all the simulation tool available in the market. So DIgSILENT come with integrated power system analysis tools that combines with reliable, flexible system modeling capabilities are there. State and art of solution algorithms can be done, and unique database management concept is there with DIgSILENT software. So now we will talk about what the base package includes. Like we can do load flow analysis here, short circuit, contingency, network reduction tools are there, and also techno-economical analysis, the analysis which are related with the economical expansion and strategies which we laid without planning the power sections. So that kind of assessments we do in technical economical analysis. Voltage stability analysis we can do. Load flow sensitivity test we can do it here in this software. Overhead line and cable parameters based upon that those calculations can be also done. Basic MV and LV network analysis can also be done. Asynchronous machine parameter, the functions which are related to the generation part of our power system, that also can be analyzed, and the transient cases which we study in our power plant, the generation unit, that kind of studies tests can be done in this software. So base package includes these some features. Now we will see in details. In load flow analysis, we can analyze both balanced and unbalanced load flow for coupled AC and DC grids. Meshed AC supergrids load flow analysis can be also conducted. SVC and shunt and tap controller are present. Station and network controlling features are there, including various inputs based upon cost, PIH, and group characteristics. Local and remote controlling options are there. Consideration of generator capability curves can also be analyzed in load flow analysis. Secondary and primary controlling features using initial responses can be also generated through the system. Distributed slack by loads and generation, including grid interchanging schedules are there. Accurate modeling of induction machines. Voltage dependent load models are available in the software library. Simple load generation scaling as well as automated feeder load scaling can be done. Consideration of temperature dependency in load flow, that if we want to check the temperature of different appliances which we have connected with our power factory system or a power factory network, based upon that we can analyze which of the system is getting more heated while flowing the charges or flowing the voltages through them. So while load flow, we can analyze the different temperature range in our network. DPL scripting and the time shift. DTC, this DPL means DIgSILENT programming language, which provide us with the dynamic inputs to the appliances which we have used in our network. Based upon that, we can give different programming inputs to our power system network and can analyze different modules and different mathematical expressions. Based upon that, we can do it here, and also can write in programming related to power system network. So also we can analyze quality factor calculations. Based upon that, we can analyze it here. So in load flow analysis, we have these some basic features which include with the DPL scripting, with the programming also. Software is basically UI based, but some programming steps are also there. Programming libraries and windows are also there. We can, if we want to program, we can program it by our own. Now contingency analysis. Contingency analysis come with AC and DC, combined AC-DC load flow analysis. Also fast contingency is screening test we can conduct. Single and multiple time phases considerations we can just conduct. Event-based post-fault actions, like we want to give a particular section of the power system with a fault creating over a particular or period of time. That kind of commands and that kind of event-based post-fault actions we can schedule on our basis. Substation automation via switching schemes we can provide through our network in the our power system, so that we can switch with the automation commands to the network, to the substations. Automatic time step contingency analysis of 24-hour time span can be done, and also can be provided with the parallelization effects of different section and different part of the section of our power system network. Generator and effectiveness and quad booster effectiveness can also be calculated. Enhanced fault cases management related to just we want to manage our fault with the whole section of power system. That kind of fault cases management can be done with the different fluctuations of time. Comprehensive spreadsheet reporting, failure including graphical visualization of critical cases can also be generated. Tracing of individual contingency cases with appliances by appliances or by the different peculiar networks expansion strategies, we can check the contingency cases throughout our model. Or if we want to trace individual appliances or section of the network, we can do also. Contingency comparison modes are there, different contingency comparison modes there. So these are some basic features which are included in contingency cases, which we can analyze in our PowerFactory simulation software. In network reduction, we just reduce our network to a more flexible and more definite boundaries, which we give for more reliable network and stable network. So for that, we have flexible definition boundaries. We can just define our boundaries with flexible definitions and parameters. Calculation of load flow and short circuit equivalent can be done in network reduction. Support of loads, WAD and extended WAD equivalents can be also done. Capturing of reduction via variation of convenient toggling between original and equivalent grids. If you want to just post with the, if we have original grid, and we can generate the clone grid with them to just check the reliability of section. If one of the grid got failure, so another will be take loading of all the section of network or not. So that kind of calculations can also be done in network reduction. So these are some features which we do in network reduction. Short circuit analysis, we have all the global and standard norms on which short circuit has been calculated. Like we support IEC standards, IEEE standards, and VDE, G74 and IEC 61363 norms. So these are different methods and different norms on which just short circuit analysis has been done globally. So these all are present in our software. Calculation of short circuit current in DC grids according to IEC 61660, and also IEEE and ANSI methods are available. We can also just analyze DC grids on the basis of short circuit analysis. Complete superposition method including dynamic voltage support of the generators connected via power electronic components are possible. Multiple fault analysis of any kind of fault like single phase interruptions, inter-circuit faults can be also done. So these are some short circuit analysis functions on which we can conduct our test. So in now in voltage analysis, we just do need to have PV curves and QV analysis. So that we can do in this software. In load flow sensitivity test, we generally see the voltage sensitivity, branch flow sensitivity, transmission and booster sensitivity. Model analysis for identifying stronger and weaker part of the section can be also interpreted in this network of the power system. So that kind of analysis, that which part of the section is more stronger and which part of the section is more weaker, that kind of analysis can also be done on this software. So in load flow sensitivity test, we have these some kind of features which are supported by the software, and we can also just go through while analyzing the stronger and weaker part of the section. Techno-economical analysis, basically this is a economic assessment of network expansion strategy. Like we want to know what will the cost of expansion, expanding a network through any particular section of a geographical area. That kind of analysis can be done in here. Net present value, method of considering cost of losses can also be done. Investment cost on a particular expansion of a line can also be assessed. Economical impact of failure rates on with the reliability analysis functions, we can do it. And also we can schedule different projects, like for a time being we can define particular expansion strategies with different specs of time, and what time it will be take to expand the network to feeder scaling. That kind of strategies we can make it here in this software. Efficiency ratio evaluation to determine optimal year investment can be also analyzed in the software. So these are some techno-economical calculations and analysis we do for economical assessment of our expansion strategies and maintenance or minimizing the losses or investment cost on a particular section of a line. So these are some features which software have for techno-economical analysis kind of studies which we conduct in our network. Now basic MV and LV network analysis. We have feeder scale feeder analysis tools, including voltage profile modules are there, different plots are there, feeder load scaling for simple and meshed feeders can be done, automated systematic visualization of feeder topology can also be done, radial feeder and tool including voltage and phasors technology, change technology and auto balancing tools are present. Backbone calculations determining the main connection between meshed and feeders can also be done in MV and LV network analysis. LV network analysis functions are just given with the different modules which we have in our library, and can also analyze that modules. Preloaded modules are there. So that kind of LV network analysis functions we have differentially, and also for MV loads. And some stochastic load modelings are also present in our database of this software. So these are some basic MV and LV network analysis functions and library equipments on which we can just analyze our network. In power equipment modules, we have a large and comprehensive equipment type library, like all the equipments which we need to design any network or to analyze any network, or basically to perform our power system functions. So all those equipments and components are available, like synchronous, asynchronous machine, motors, generators, W-fed induction machines, stator generators for modeling wind and PV generators, fuel cell and micro turbines, etc. Wind turbines and PV systems are present in this software. As you see, this can be analyzed with the system. We can make it hybrid or totally renewable, based upon renewable sources. So PV systems and wind generators are there. During these days, complex study for integration of wind generation into distribution and transmission network have become very important. And PowerFactory comes with the standard in wind generation modeling, combines extensive modeling capabilities with advanced solution algorithms, thereby providing analysts with the tools to undertake the full range studies required for the grid connections and grid impact analysis. Some of the study cases we just generate on the wind generators, like steady state load flow calculations considering voltage dependent reactive power capabilities, and also providing the limits to wind farm controllers and with the set point characteristics. Short circuit calculations can also be done on wind generators with optional inclusion of dynamic voltage support according to K factor settings. Power quality assessment according to IST standards can also be done on wind and PV systems. Stability and EMT analysis can also be done. Wind turbine models for establish of generator and converter types can be done. Additional wind plants equipment such as control shunts and STATCOM facilities are there. Some stochastic wind models are also present for adequacy studies in this software. And for PV systems, we use PV cells featuring integrated for power calculation based on solar radiations. So that kind of calculations can also be done on this software. And a lot more components like static VR compensation and shunt filter models, simple and complex load models and reload models, and different networks and different branches like line couplings, tower geometries, cable systems, two winding transformers, auto transformers, three winding transformers, DC to DC converters, inductive DC couplings are there. Power electronic devices consist of thyristor, diode, VSC, DEC valve, soft starter, etc. are available. Yeah, we can design and simulate FAC devices in this PowerFactory software, and also can analyze HVDC systems based upon that. Control objects such as station and secondary controlling features with the transformer, tap controller, virtual power plant. If we want to create, we can just create it. Capability curves based upon that we can design. Protective devices library like the functions based on static and dynamic functions of protective devices, both are present. Fourier sources, harmonic sources, FFT and clock, SNH, etc. are available. Parameter characteristics basis of scalar, vector and metric files can be provided to the software for modeling of load profiles in wind and PV systems can be done. And also the temperature dependent load and variations in the load flow studies, we can do it here. Grid organization and element grouping, if you want to provide some specific zones and areas and boundaries, circuit routes, feeder, operator, owners, that kind of definitions we can provide to our network. So in power equipment model, these are some different appliances and the capabilities of software available with these some power electronic devices. So we can use in our network for designing and having better results. So software is basically a very versatile one with all the equipment available in the library, and you can also design your user specified load models and also import from different sources to this software. So these are some power equipment models, capabilities and features which we have in this software. Now network representation, in which we support any kind of network, either it is mesh or radial, and one or two or three or four wire AC and DC network. With the combined AC DC network can be also just analyzed and drawn in this software. Single and single phase, two phase, biphase, three phase technologies with or without neutrals can be also analyzed. Detailed primary and secondary substation models are there. Single and double bus bar with the tie breakers, bypass bus bar, and two bus bar systems. That kind of GUI tools are available, and also the tabs for buses are available, extendable for the user specific bus bar configuration. If you want to put circuit breakers and different protective schemes through your buses, you can just drag it from our library and can put in our buses. Switch and substation equipment such as circuit breaker, fuses, disconnector, loads, brake switches, grounding switches, NEC, NER, surge arresters, CTVT, CVT, etc. are available. So these are mainly power electronics protected devices which we have in our software. Also, we can run arrangements and switching rules for substation automation in network representation module and featuring. So these are some network representation features which we have in software. Now we will talk about the advanced functions. In advanced functions, we have protective functions. cable sizing, we can just analyze through that. Distributive network functions are there. Power quality and harmonic analysis, we can do it. Arc flash analysis we can do. Reliability and analysis functions based upon optimal power flow. Stability analysis functions like RMS, root mean square value simulations, electromagnetic transient simulations based upon that we can analyze. Also, eigenvalue analysis based upon a small signal stability can be analyzed. In state estimation can be also estimated and analyzed in this software. Motor starting functions, including scripting and automation, can be also provided. Like I have told you, like we can use DPL for scripting and automation. We can just follow the command and give algorithms, and on basis of that we can calculate our network. JS and SCADA integration is possible. The software supports various interfacing options, including bidirectional data exchange with GIS and API utilities, online reading of dynamic SCADA data, as well as import static data can be possible. Engine integration with SCADA systems can also be done. Optional interface of OPC SCADA standard systems and analog digital signal interfacing can also be done with this software. OPC is basically a platform which gives as a emulation part that can be the software and hardware systems can both run simultaneously, and also you can use your software as an analyzation part and with the live systems. That kind of lab has been situated in IIT Kanpur. They are using for real-time digital simulation in RTDS lab. They are using this software for real-time digital simulation. So they are using OPC server is a component which work as an emulator and give platform for hardware interface to the software. So that can be possible, that software can be interfaced with the hardware systems and can also integrate with the GIS system. Now protection functions. Protection functions, we have a comprehensive library with the relay models suitable for steady state, RMS and EMT calculations. Synchronization with stationware. Stationware is a different part where we design stations and like virtual stations, or it is also a software only. Collect the data of a station, and load flow scaling has been done in a stationware where we can design our own stations. So synchronization with the stationware is possible. Highly detailed relay setting spreadsheet reports are there. Graphical visualization of editing fuses, relays, and CTVT are possible. So these are some protection functions which we have. We have time over current protections, distance protections, and also have directional relays. So these are some protection functions we have. Now we will talk about load flow transmission. So fast and accurate load flow algorithms just software go through for analyzing load flow transmission. Full Newton Raphson current iterations both can be select and analyzed through our network. AC and DC network for HVDC transmissions can also be done. Secondary power controlling controls are there. Primary controlling features are also there. Secondary reactive power controlling voltage control profile can be possessed in load flow analysis. Also, we can profile our loads through different section of the period of time. Also generate PV curves based upon that, our load flow analysis. All type of sensitivity based upon dV by dQ and branch sensitivity test we can conduct. Model analysis based upon dV by dQ can also be done. So load flow transmission have these some features which included this software and lot more when we do software analysis on software. I will show you. Load flow distribution have any type of network topology like three-phase 4-wire, two-phase, bi-phase, single-wire, earth return DC networks. Any type of network topology is mesh or radial, both can be analyzed. Secondary like suited for extremely large ambient networks, more than 20,000 bus bars. can be also analyzed. So the educational version of this system, this software, come with 50 nodes and 50 bus bar only. That we can just create our system with the 50 buses limitation. But the research version is come with unlimited nodes and unlimited bus bars. So we can create our system more than 20,000 bus bars above, and can also analyze it through our distribution channels. If we just collaborate these systems with GIS, this software with GIS, and there we can plan our network through a peculiar area. Like we want to draw our network through a whole Delhi transmission network or distribution network. We can just go above, I think, 20,000 bus bar. So there we need these kind of softwares which will analyze throughout accuracy and throughout all the network. This software is extremely suited for that. Voltage profile diagrams on the based of that we can get. Stochastic load modeling consideration, load diversity in LV networks we can generate. One or two dimensional load profiling modules are present in there. Feeder scalings and open point optimization can also be done in this software. So these are some load flow distribution methods and different functions which software is collaborated with. Active and reactive power dispatches which we usually give with our generation unit of a power system for minimizing the losses, and also for fuel cost minimization in production of power. Branch flow limits we give, bus bar voltage limitations, active and reactive power limitations, and also analyze the stator current limitations and reserve constraints. If the system is gone reserve, so on that how should the power system will run, that kind of considerations can also be done in the software. In stability test, we just analyze transient and dynamic stability, so that both transient and dynamic stability can be analyzed. High and accurate generations and load models are there. Just we can take and analyze our stability test through them. Large library for standard models are present. User-defined modeling capabilities are present in this software. Variables, step sizing algorithms. If you want to write our own algorithms, we can write in this software. Interactive event definitions we can create with our programming. Small signal analysis, also model analysis can be done on this software. Now electromagnetic transient, we can module our network to the detailed networks. Transformer saturations we can analyze. Transformer capacitance, distributed parameters online, and distributed detailing switch, and power quality assessments, electronic devices modules. Easy to chart definitions can also be done. Interactive event definitions can also be processed throughout the system. Variable step sizing algorithms, based upon our programming section, we can provide various steps for algorithm we can give in electromagnetic transient. For overcurrent protection, we have CTVT modules, fuses, OCT relays, directional relays, differential relays, and also including LV circuit breakers. The software can be coordinated with the selective diagrams. If you have any peculiar diagram for protection devices, we can just fill the parameters based upon that while coordinating the software with the selective diagram. Simulation we can do like a steady state and time domain both on our overcurrent protection devices. In distance protection, CTVT models, MHO characteristics, quadrilateral characteristics, XR blinders, starting characteristics, and inter-tripping schemes. These kind of modelings we do in distance protection devices. So it can be coordinated with the RX diagrams if you want to see the results in RX diagram, and time distance diagrams. Both kind of diagrams is supported by the software in distance protection. Simulation based on steady state and time domain both can be analyzed. In harmonic studies, we generally do balance and unbalanced harmonic sources studies. characteristics and non-characteristics, and inter-harmonic load flow analysis. Also, frequency and time domain charts. Based upon that, we analyze. The basic feature is to conduct harmonic load flow that we can do. Also, we can analyze our frequency scans, and also we can select the frequency dependent line parameters, distributed parameters through different line models we can generate. Also, filter sizing, we can give different specs and analyze our filters through them. So these are some harmonic cases and harmonic features which we have in this software. In reliability assessment, we have some standard models like Weibull Markov failure models are there, and also we analyze in reliability like line transformers and bus bar failures, common model failures we analyze, double earth faults, circuit breaker failures, protection failures, and state elimination analytical process has been accepted in this software. And also we can do Monte Carlo simulation in reliability analysis. Advanced system restoration model including generator dispatch and load shedding methods are there for restoration of generation in any section of the network or whole section of the network. That kind of reliability check we can do throughout our section. Independent second failure is also there. Protection and circuit breaker failures can also be created to analyze the different faults through the appliances in the network which we are using. I already told you that we have wind power and PV systems which we can analyze and use as a generating unit, or we can create any hybrid systems here. In wind power, we can analyze the W-fed induction machines, converter driven synchronous machines are there, HVDC light systems we can just draw, noise modulation facilities are there. Based upon that, we can do noise modulation. Tower blades and blade mechanism can also be provided. Pitch controlling and graphical features based upon that we can give. And different graphical control modeling facilities are there with the wind turbines. So these are some basic features in wind turbine models. Now, lastly, DPL, which stands for DIgSILENT Programming Language. DPL is object-oriented scripting language. Is initiative to easy to learn. The basic steps are commands like we can give command if, then else, or do while. Input and output and reporting routines we can generate. We can also feed mathematical expressions through our network. Execution of PowerFactory commands we can just provide. PowerFactory object procedure call also can be done. So these are some programming features which we have in this software. Based upon our requirements, we can just program and give different inputs to our system and commands to our power system software. So we'll come to this after completing. Now I will show you how the software look like. So this is the designing window where we used to design our network. This is the output window, and these are the various appliances available with the designing part of our network, like wind generators are there, PV systems are there, synchronous machine, different loads are there, MV loads are there, LV loads are there, also two winding transformers, some converters, DC to DC converters, rectifiers, inverters. So these are some basic features, basic components which we use in our network and can implement in our network for using the system, and can generate our desired network model. While simulating part, these are some different simulations like contingency analysis, quasi-dynamic simulations, RMS EMT simulations, model analysis, harmonic, reliability. So these all we can just conduct. While doing, if I am doing contingency analysis, I have to select contingency analysis. Then the tab here, it will change, and it will generate the tab related to contingency analysis cases. If you're doing quasi-dynamic simulations, we have to just click on quasi-dynamic. It will be generate tabs related to quasi-dynamic simulations. If we're doing RMS simulations, you can see, or just it will generate the cases of RMS simulation. So likewise, we can analyze these some of the functions, and also we can test load flow and short circuit analysis. Now I will show you how to draw and what are the features available in the library. So for analyzing and drawing network, firstly we have to put buses. This is a single bus bar. This system is consisting with 3 buses, and for that I have to give one generating unit. So this is a generator acting as a generating unit. This is a load. This one is a line from second bus bar to last bus bar. So this is our network. I have completed drawing. You can see synchronous machine, single bus bar, winding transformers, line, and load is the general load. So when we have to fit the parameter, you can see just you go to type, and you have to select if you want global specs. You can see 110 MVA, 255 MVA. So these are the global parameters which synchronous machine works. So they already preloaded in the library. You just have to select, and you can import it from there. If you're doing some project and you want the same specs generator should be used in this peculiar example also, so you can just save your project data, and you can import that specs from there also. New project type, you give your own specs like nominal apparent power, nominal voltages, power factors, and types of connections. If you're doing the load flow analysis, you have to give different reactances values, reactive power limitations, zero sequence and the negative sequence data. If you're doing short circuiting, you have to give like negative sequence and zero sequence reactance, resistance, and also saturated value, subtransient reactance, reactive power limitations, short circuit impedance, time constants, saturation tables. These all vary to like experiment by experiment. Like if you're doing ANSI short circuit, ICS and the short circuit. If you're doing RMS simulations, so we have different models. We just will go to click stator resistance, rotor type. We can just define transient reactions, subtransient reactions. So these are more detailed parameters which we can feed. Also can give graphical inputs. Also define the torque coefficients and damping torque coefficients. Speed variations also can be done. Same in EMT simulations, different and damping factors can be designed. Also can give the resistance and reactance values. Harmonic, they are different. You have to give the readings and feed parameters. Protection, it is different. So likewise, based upon your steady cases, you just have to give all the parameters. In load flow now, like in general input mode, like what kind of input dispatch the synchronous machine is having, spinning if circuit breaker is open or not, like that kind of calculations. Based upon Q characteristic, local controlling options we can provide, reference machine we can take, active power, reactive power, primary frequency bias, these all can be defined. Operational limits can also be defined, and graphical inputs capability curves can be also drawn based upon that. Also, you can define with the users like active power, minimum and max MVR. That kind of specs can also be provided. Just if you have data, you can copy it here with this software. You can also provide and create virtual power for better analysis. And if you want to create your own power plant, you can just create it. So these are some basic functions you have to fix before you going to derive any specific analysis. You can also select it is working as a generator or motor. While plant category, if you have plant data with you, you can with the research version you can select that its generator is where it is placed. Either it is working in a coal power plant, oil or gas, nuclear, hydro, wind, biogas, solar power plant, or pump storage or other. These kind of definitions we can just provide to our network while working. If we have the plant models. So these kind of specs come with all the equipments having the same specs. Like you can get the global type libraries, global type, project type, and new project type, where you can see 50 and 60 because we are seeing a two winding transformer. Now come to this line. You can check here global type 10 Kelvin, 10, 15. So these all equipments having these kind of libraries and also user defined libraries. So all the users come with the software inbuilt manual. You just have to click in help. Just it will take you to the manual, PDF manual, which is present in the software. So these are 22 different simulations from load flow analysis, reliability assessment, contingency, protection, state estimation. So these are 22 different simulations which we can do on this software, and the manual is having all the introductory part and what we can do on this software, how to analyze, how to design the system. Everything is said in the software only with the manuals, and also have video manuals. When you just open it, examples, here it is. So different examples like examples related to LV networks and NV network, transmission systems, industrial network, wind farm. So these are the video examples consisting how to draw, how to design any network, how to create any model on this software. Like these are the videos which will work as a video tutorials for you while working on any particular section of experiment. Some additional examples are also there, like 9 buses, 14 buses, 39 buses, and also on standard norms, paper published like IST standards. Different papers are there, IEEE, and some other examples are also there. So in LV distribution network, I will show you the one section of a network which is more than 20,000 bus bar. I'm just importing that file from a database of the software. So that LV network consisting of more than 20,000 bus bar. It containing two sections. One is of 0.4 kV distribution, and then I'm just opening it. It's taking too much time. So this is our network consisting of 0.4 kV. So this system is more than 20,000 bus bar. Above. You can see it is gone to feeder scale. Basically, this system consists of GIS graph is there, but here it is not showing you. So on basis of GIS, they have designed this distribution section of 0.4 kV, and this is 10 kV diagram, 10 kV system, and this is the main 30 kV distribution section where it's coming from a grid and going to substations. So this system consists of more than 20,000 bus bars. So these kind of analysis can be just and get accuracy through all the 20,000 bus bars. And bigger sections of networks can be also analyzed. So now I will take you through transmission system and we will analyze some of the systems. The software is containing all these examples in database only. You just have to click on import and it will import from the database. So basically this is a hybrid system which is having two wind park, like wind park east and wind park west, and also connected to the different generating units, like these are the generating units available. So this is the overview diagram. Now I will show you a single line diagram of this. So this is the wind park west. This is wind park east. You can see the wind turbines. This is a wind turbine, static generator using as a wind turbine. Category wind generators. You can just select photovoltaic or other renewable generators, fuel cell, HVDC terminals, reactive power compensators, or storage devices. So these can be analyzed. So this is a system. Now I will run a load flow test. You can see the calculation method based upon AC load flow, balanced positive sequence, AC load flow unbalanced positive phase sequence, and DC load flow analysis. Reactive power controlling features are there. Temperature dependency on line cable reactance are there. Loading options are there. In active power control, as a dispatch, according to secondary controlling features, primary controlling inertias and active power limitations we can do. Balancing also is available. Advanced option is load flow method. We have Newton-Raphson current iterations equations and also Newton-Raphson power equations, classical method of analyzing load flow. We have different station controlling facilities and modeling methods also. Load flow initialization also can be changed. That adjustments can also be changed. Iteration controls, you can just give in how many numbers of iteration, just going to calculate that. Output loop you can also define. Loading scaling factors can also be generated, can analyze. Low voltage analysis can also be done. Fixed loading and load profiling can be given. Definition of variable load power customers can be also given. Voltage drop analysis can also provided to the system. Advanced simulation is come with the models, consideration for productive devices and main backup systems. There are kind of analysis we can do it here. So now we execute load flow, and you can see through the output window the calculations are going on. If any error will is there, it will show in red, and they will just generate an error that load flow command cannot be executed. That kind of error come when the parameters and everything not fixed and not given peculiarly. So just for background calculations, we can see the start Newton-Raphson algorithm, load flow iteration, 1, 2, 3 iterations are there. Based upon that, they have calculated. Now we can see calculations, because I have tested load flow calculation of this network. So you can see different branch flows like PQI values through different sections and all parameters through the network, like loading and everything. PQI values are there. You can just also change on your user defined, like if you want to see current and power factor, and also tripping time and fault clearing time. Based upon that, you can just analyze. So these are some basic limitations and standard parameter specs on which we want to see the load flow. We can just generate. Empty comes with if any of the system is empty. If you want to see the system empty, not with all the analysis, we can just select it to empty. You can also analyze and edit our edge elements, and also format the line with different flows. Also, we can define our text boxes in which we can analyze our system through our user defined values. So this is a load flow calculation throughout the system. Now you can see short circuit calculations. Basic methods like VD, NSI, complete, IST standards, IEEE, and different norms. So these are different methods. Based upon that, we can calculate our short circuit. Fault type like fault type 3-phase, 2-phase, single phase. Different fault cases can also be generated. So these are all the calculation methods which we have in short circuit. Also maximum voltage and short circuit duration, fault impedance, fault location can also be user defined or user selected. And also we can give user identification based upon voltage factors, asynchronous motors, conductors, and different verifications we can provide to our system. So in load flow, we have different methods. Fault types are there. Maximum, minimum we can define. Published here based upon that norms in which year it is published. We can select and execute our load flow. Use break time as a global or a minimum of local or local. We can just define it. So these are some basic features in load flow analysis which we analyze. Now we will see the detailed reporting of the system through our load flow calculation. So load flow calculation will create the detailed report of all appliances which are used in this network, and will conduct the test, load flow test through all the equipments and all the portion of network, and give detailed reporting which we need to use for analyzing the load flow analysis. So the analysis is going on. You can see different loading values reactive and active values, scaling factors are there, active power limitations, and different values which we used for defining our load flow. So some stochastic models of generators based upon that they have calculated, and for all the section of the network like step groups, controller time constants, turbine factors, frictional losses, turbine rated power. So it's been actually this will calculate more described way, like they are calculating with all generators and all equipments which are connected. You can see the grid. Based upon that, all equipments are being analyzed and reading through and load flow test through all equipments in the connected network. So this is our total load flow analysis. With all equipments in the network with the more detailed reports. Now I will run transient stability test. So for that I have to run and create a section with short circuiting. I will generate short circuit on this line, and the simulation will run for 20 seconds. And so we have give time in seconds. If you want to display results in microseconds, it will show in output window. So just I will execute it, and you can see the simulation is counting with for 20 seconds, and we obtaining the graph of three of the generators used in this network, like S5, S12, and S11 generators. Their graph on rotor angle with the reference to machine angle. So these generators, we are testing the rotor angle plots on them and checking the transient stability of the system. So this is our graph of S5, S12, and S11 generators, and just we have analyzed for 20 seconds. This is the timing which we have given for analysis. So you can see now short circuit has been generated here. I told you that the system will go out as circuit breakers has been used. So this is out of connection, out of the network, because of this line has been tripped by circuit breaker, and this is a point of short circuit. The short circuit location is at 50% of the line, in half distance of the total length of line, and the length of line can be also analyzed like 200 kilometer the length of line, and error is occurring at 100 kilometer of the line. So these are some transient stability cases and some functioning of this software which we can work on. And another I will show you on wind farm. This is a 15 megawatt wind farm containing 6 wind turbines with fully rated converters connected via 20 kV distribution. So we will analyze some power curves and also some calculations. Harmonic calculation based upon that. So I will show you. These are the wind turbines, 6 wind turbines used in this network. 6 wind turbines used in this network, and these are the conversion and converter part, and again distributing to the grid. So these are the I told you that we can define the owners and distribution systems, and also the generation functions, different voltage levels through the section of line. So these generate heat map, that which part of the section is more heating and which part of the system is less heated. That kind of analysis throughout the system we can do. So now we see some power curves. So we'll run time series analysis. So this is the plot of active power at converter, and also the different losses inside the wind farm. This is a graph. Red shows the active power at PCC converter, and different black shows the losses in the wind farm. So this is the plot we got from a network, and these are the active and reactive power at converter. Wind speed, input mode is cos VH, reactive power, wind speed, reactive power, and active power at PCC. So these are graphical analysis of wind turbines which we are using. Now we'll go to short circuit. I have shown you already short circuiting, so now I will just take you to harmonic tests. So now I have to change, like we are analyzing for harmonic load flows. So I have to check, click to harmonic. Now you can see the harmonic load flow. We can execute it from here. Also, we can calculate the harmonic single frequency, all frequencies, different IST standards, advanced options are there based on HD and THD calculation threshold values, like that. Calculate harmonic factors, RX, calculate RX and output frequency nodes, calculation of K factors can be given, balance, unbalance, this kind of. So we will calculate our harmonic. So this is bus bars voltage distortion, the graph of distortion of voltages in different buses. This is harmonic voltages at different buses. This is transformer and grid current, harmonic current at grid and transformer. So likewise, we can do different 22 different simulations on our this software and can analyze our system. We have some additional examples. So offshore wind farm is also the state estimation is there. We'll analyze 39 bus system. So this is our 39 bus system. You can see 39 buses, and our whole network consists of 13. You can see voltage magnitudes to different voltage levels. Yes, I will run the simulation. These colorings denote the different loading and voltage rangings. These are the voltage magnitudes at all the 39 buses. These are the voltage angles at all the 39 buses, and this is the generators active power and reactive power graph. So these are some basic analysis related to power flow and power quality. We can just assume, and on the basis of that we can design. Here you can see the generator 10 has a loading of 29%, and generator 8 is having loading of 77.1%. So the system is consisting of 39 buses. So we can see all the 39 buses voltage magnitudes, 39 buses voltage angles in degrees, and active and reactive power of different generators used in this system. So these are some features, basic features and through, and wanted to show you the basic capabilities of this software. Many more are available. If you have any specific questions, now you can ask to me. Hello. Hello. Yeah, MATLAB integration is there. We have different MATLAB integration modules. Like I can see you the manual. So we can integrate it with the MATLAB. So we can just we have a MATLAB interface. We can use our different sections. These are the DSL modules. We can interface with the MATLAB. Yeah, PMU unit is present in the DIgSILENT, sir. Yeah, we can simulate voltage stability for microgrids. I will send you different papers published on this. Sarita ma'am, I am just will after this webinar session, I will send you some papers which are published for simulating the voltage stability in microgrid system. On your mail, I will send you.
Thank you.
Any more questions? Thank you, ma'am.
Thank you, sir.
Good afternoon. Hello.
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 Good afternoon, Ravi sir.
Yeah.
Good afternoon.
Yeah, sir.
This is Kiran from SDM College of
I can hear
Engineering.
you.
This is Kiran from SDM College of Engineering, Karnataka. So I'm a master student.
Yeah, sir.
I need to know whether artificial intelligence toolbox is there in this software or not.
No, artificial intelligence toolbox is not there, but we can program it.
Oh, okay.
Like with the variable inputs, we can provide it to with the programming scripting, and Python program is available with this software. So we can just program it. Any more questions?
Hello. What?
Yeah.
Sir, regarding wind plants. So can we design UPFC and IPFC in this one? And STATCOM devices?
Yeah, STATCOM are possible to design, sir. Additional
UPFC
power
and
plant
IPFC?
control trends and STATCOM are available with this software.
Is it UPFC and IPFC are available?
Yeah.
Hello. Can we have control design parameters? Can we have a control strategy? Can we design
Yeah,
a
yeah, we
control
have
strategy?
control fronts. Yeah, yeah, we can design control
Okay.
fronts and control strategies are there.
Okay. Can
I
I
will
have an
send you
information
all
about that?
browse checks and also the
Okay.
details, more details. Please let us know any more queries
Case
if
studies
you
if you
have.
have.
Yeah, we have some case
Any
studies.
came
We will
any.
link you to that.
Okay. Okay.
Hello.
So
Uh,
I will be waiting for your mail, sir.
if you have any specific questions, please write us mail. We'll respond clearly on the mail because your voice is not coming clear to me.
Okay, okay, sir. Okay, I will
Okay.
mail you the things which I need.
Yeah, just let us
Okay,
know.
thank you.
Just even you can just ping us on our cell
Thank you.
phone. Okay.
Okay, sir.
Thank
Okay,
you.
thank you, sir.
Anyone more question? If you have any question, please write to us, or if you can write on chat box, you can just write. Yeah, ma'am, you can leave.
Thank you, sir.
Okay, nice to have you all on this webinar session, and thanks for coming. Now I'm just completing and closing this webinar session. Thank you, everyone.
Thank you.